Hi everyone. Today I'll be doing a live coding demo of me looking at Heaven of Code 2023 day 5, coding up the solution in Python. And yeah, I'll be going in blind so you can see my thought process and the decisions I make as I approach this problem. From what I've seen online, this one is a little tricky, especially part 2. So hopefully we'll be able to get through it. But yeah, let's just get to it. Again, I think I'll read through the story just because it's kind of fun. If you don't want to hear that, just skip forward maybe a minute or so. All right, day 5. If you give a seed a fertilizer, you take the boat and find the gardener right where you were told he would be, managing a giant garden that looks more to you like a farm. A water source. Island is the water source. You point out that Snow Island isn't receiving any water. Oh, we had to stop the water because we ran out of sand to filter it with. Can't make snow with dirty water. Don't worry, I'm sure we'll get more sand soon. We only turned off the water a few days, weeks. Oh no. His face sinks into a look of horrified realization. I've been so busy making sure everyone here has food that I completely forgot to check why we stopped getting more sand. There's a ferry leaving soon that is headed over in that direction. It's much faster than your boat. Could you please go check it out? You barely have time to agree to this request when he brings up another. While you wait for the ferry, maybe you can help us with our food production problem. The latest Island Almanac just arrived and we're having trouble making sense of it. The almanac, your puzzle input, lists all the seeds that need to be planted. It also lists what type of soil to use with each kind of seed, what type of fertilizer to use with each kind of soil, what type of water to use with each kind of fertilizer, and so on. Every type of seed, soil, fertilizer, and so on is identified with a number, but numbers are used by each category. That is, soil 1, 2, 3 and fertilizer 1, 2, 3 aren't necessarily related to each other. Jeez, it's complicated. Alright, for example, so I've got seeds, got a bunch of different fields, soil, fertilizer, water, light, temperature, humidity. Okay. Okay. The almanac starts by listing which seeds need to be planted. The rest of the almanac contains a list of maps which describe how to convert numbers from a source category into numbers in a destination category. That is, the source that starts with seed to soil map describes how to convert a seed number into a soil number. This lets the gardener and his team know which soil to use with which seeds, which water to use with which fertilizer, and so on. The maps describe entire ranges of numbers that can be converted. The destination range start, the source range start, and the range length. Okay. Destination range start of 50. Okay, so the range lengths are the same. Okay, so seed 98 corresponds to soil 50. It's got it. Let's try to understand this a little bit. So here we have 15. So here we don't have like a seed to soil map for 13 and 14, as I understand it now. 55 would be addressed by like this thing, and so on. All right. Okay, and if they aren't mapped, then they have the same destination number. Okay. Got it. Got it. So it's looks like, yeah, we're going to be having to basically parse this into some kind of data structure and then navigate the data structure to find some value. The closest location that needs a seed. The lowest location number that corresponds to any of the initial seeds. Each seed number through the other categories until you've... Okay. Got it, got it. So let's try and do this example by hand, and then try and implement a solution maybe. Well, I'm not going to do it all by hand, but let's just do 79. So 79 is in this mapping. So basically 52 to 50 means we're shifting down by 2. So this is going to be soil map 77. Let's check what that is, what this is saying. 81, wait, what? Seed the soil. Okay, it's a little bit weird here this is seed to soil map, but this is like the soil and this is the seed. Wow, yeah, it just seems a little weird to me, but whatever. So this is going like essentially +2. So 79 is going to 81, which, yep. And 81, we're putting it through this next map. So basically, like, these have different names, but these are all sort of doing the same operation. So 81 is going, I believe, yeah, it's not going to be covered by any of these ranges, so it's staying 81. Then, similarly here, it's not going to be covered by any of these ranges. Then here, we have this one. So this is doing like a -7 operation. So that's going to be 76, 74. Okay. 74. Then 74 is going to go... It's going to be in this map, which is +4, so to 78. Alright, yeah, I think I'm doing this correctly, so we don't have to follow it all the way. It's a little complicated. But yeah, basically what I'm doing is looking at the seed, and then, or looking at like each value as we successively go through this. So if we have value 79, then I'm looking at which one of these is lower than or equal to this value, but has range such that this plus the range. So this is covering like 50 to 98. So this will go in here, and then what it's mapping it to is like essentially like this minus this, so that would be like +2. Yeah, I hope that makes sense. All right, after all that, let's get this example running. So looks like that we're fine. I'll just grab the input too. Which is quite large. So we'll have to think about how we do this. Yeah, it's good that we looked at this. Since these numbers are really big, we're not going to be able to store like the explicit maps. Meaning like, or at least that doesn't seem like a great solution. Like this like explicit map that has a seed to soil for each number, we could create that here, but that would be quite difficult. Yeah, so I think the exact data structures we're going to want, I'm not entirely sure, but let's just start coding and figure it out from there. So I'm going to set up like I did last time using this watch.py utility. Okay, so that's working. And then I just use a little template here because I've been doing this for every problem, so it just made a little more sense to create a template. All right, let's get into it. So I think we'll want to create, first let's get the seeds. We'll use a little regex to do that. So the pattern is we're matching all of the numbers, in the first line. Cool. 79, 13. And then let's just cast these to integers. Here's actually a little question for someone in the comments. So right now we're creating like a list here, but what if instead, oh, that's not what we want. Create like a tuple, because I don't think we're going to want to modify this. Okay, well, it just prints weird. But are there like instances where we'd rather want to create a tuple versus a list? Talk to me about it. Obviously, like the tuples can't be modified, but it seems like it's doing something weird. All right, that's big tangent. Let's get back to the problem. So we have our initial seeds, and then I think we're going to want some sort of data structure to store each one of these maps. And I think, let's maybe parse it first and then worry about how exactly we're going to want to store it. So we have our seeds. Now let's go. So I'm iterating over the lines here. Maybe we do. Trying to like do some sort of iterator thing, but let's, yeah, maybe that is making it more complicated than it needs to be. Because we basically are going through these lines. Geez, this is. I mean, there's a messy way to do it. It's just annoying to have to parse this. So start on this third line, and then initialize the map start to I guess Guess we didn't need to do that. Yeah, sorry for not talking. Let me just... yeah, okay. So this long, complicated way of just getting the line number in the line, starting for the second line. Yeah, and then we want to keep track of creating this variable map start that'll keep track of each like map that we're in. So if line, so if we have text on the line, so if we have text on the line and we're not already in a map, let's set the start. I guess we don't need to, this can just be like in map. So basically, this in map variable, I know this is messy, but I'm just not really sure the best way to do this. This in map variable is could be true if we, like, as we iterate through, like, I want it to be true while we're like inside this block, then false here, then true again, and we'll sort of use that to iteratively like, create our map. So I think, so in this case, if the line has text and we are already in a map, what we want to do is get the numbers using just this same little thing. This capture group. This really is going to be, I think, the easy part of the problem, and we're struggling a little bit, but patience. Let's cast these to integers too. So otherwise, that means we don't have a line, in which case, then let's just break here. So map will be a list of these, and then maps will be a list of the map. So like map will be like map 0, map 1, map 2, map 3. And then like this will be like map 0, map 1. And then let's just see what we're working with here. So 1598 to and then, okay, gotta reset the map each time. And what is going on here? Let's get rid of this. Jeez, so stupid. All right. Okay. Okay, so this should be the maps for each line. This is the seeds, and then I think this is correct. Maybe instead, I think we'll have to, yeah, like I said, with the data structure, we'll have to sort of iteratively figure out what exactly we need. I think instead of just having this line numbers be flat, let's instead do something like, what do we call these? Source, destination, and range length. This is range is a keyword. We got RGE. I don't know. And then, yeah, I guess we can do. I wonder if this is the right way to do it. Probably not. It's probably a better way to do this, but whatever. Okay. So that's that. Yeah, this is obviously quite messy and probably, I don't, maybe it's a little brittle, but let's for now just stick with what we have and try and write the code to actually go through these maps. I guess this is sort of like a map list. Yeah. Whoops. Change the name of this to map list. Okay. And then we sort of have to traverse this, I guess, for so we're just going to try and do this for one map for one seed. Let's get rid of this. What does this call this? Yeah, I guess the maps, whatever. Follow each seed through the maps. Okay, so we're gonna look at yeah. Since we're sort of be tracking this value, the seed through these maps, let's just create a new value for it. So we have, starting with 79. So like I said before, we want to find the lowest source such that 79 is greater than the source. So I think, yeah, let's have the map list let's sort these by it's key. Jeez. Okay. So I think this is going to make sure that when we're iterating through this map list, the lowest source is going to come first. Yeah. So now I think we want to find, like, within this map list, which one of these applies to our current value. This is just, these names are becoming really messy, but let's just deal with it for now, and then if we need to refactor, we can. So I think we want to compare, check if basically we want to check if the value is greater than or equal to the source. I guess we don't need to create any variable here. Is greater than the source, and value is less than the source plus the offset plus the range, sorry. Yeah. Let's make this a little bigger so we're not going off the line, the edge of the screen. So in this case, we want to use this mapping. So I guess maybe the sorting is not necessarily required, but whatever. Yeah, we're gonna just update our value. And the way we do that is by calculating the difference between the destination and the source. So essentially, what we want to do is do okay, so right. Let's just try and follow the path of the seed and see if we're getting the right answer. So we're ending with 47. Okay, which is not entirely correct because this thing is flipped around, which we already did. Although is this? In which case we're ending up at 78 because we're not printing the value at the final time. We are. So we're going 79, 81, 81 again, 81 again, 74, 78, 78. So basically, I think what we're missing is, we're missing the final list, which is going to be mapping. We have the 0 to 69, so we're missing this final map. So I think here, since we sort of need like this empty line to reset things, let's just append an empty line. Or maybe what's better than that? Also, we're not using eyes, so this whole thing I did was totally worthless. Here, I'm instead of appending an empty line, I'm just gonna mess up the lines variable, which is okay, we're getting to 82. Just please let that be right. Nice, nice. Yeah, let's, instead of breaking here, let's just go through this, see if it works. Oh, why is it minus? And, okay, so, all right. Let's do a little debugging. This is just really parsing nightmare. This would be the easy part of the problem. I still have faith that we'll finish within 1 hour though. Okay, so yeah, let's just try and follow the path of each one of these values. So let's do maybe this 13 that's just getting all messed up. And see if we can see any problems. Okay, it's 13. It's not covered by either of these, so it's going to be mapped back to itself, which we indeed do. Now 13 should be covered by this. It's possible. I think it's possible that I'm looking at, I'm here. Yeah, God, this is so stupid. This needs to be the destination. But then this was right before. It's literally the exact same problem I did when going through this on my own. And now we have 21, 51, 20. Which is still wrong. Okay. Yeah, so 79, 81, 81, 81, 74. Okay, so this is 74 to 46, which is light temperature. For the numbers again, it starts at 74. So that should be hitting this one. And then why are we going all the way to 46? That's just quite strange. Yeah, so let's little breaks. We're only looking at the first example. And when we here we should break. I just am not sure if that for now, I think, yeah, we had to break, I guess. I think at the very end, if you're not understanding what's going on here, well, let's just try and talk through it, I guess. But basically, we're just implementing the logic that I talked through. So, like, for each, got this triple nested for loop. For each seed, yeah, let's just submit this and see if it's right first, and then we can talk through it. 35, which is right. Let's run this on the full input. Number, but it didn't give has like a negative number or an error. So nice. Okay, yeah, let's just talk through. This is just parsing, so I hope how this works makes sense. Now let's talk about sort of how this mapping works. So we're looping over the seeds, but then for each seed, we're following its path through the maps. And then sorry. Basically, yeah, going over the map lists, and so this is like what I'd call a map list. So we're first looking at like this, going through this map, going through this map. What I call like a map list, this just calls a map. So that's why the names I guess are getting a little confused. And then each one of these individual ones, I don't know what it calls. The lines, whatever. We'll just call it the map dict. That's fine. So essentially, inside of each one of those maps, like each one of these maps is like value to value, right? And we're just chaining them together. So then, like in each one of the maps, we look through each one of these lines to see if it's applicable to our case. And so if it is, like for example, if this line correctly, like in the example we've been going through, 79, it's going to map it to like +2 because 79 is greater than 50 and less than 98. Excuse me. Then we're going to have 79 to 81. But we're sort of like iterating through. So first we look at this map. Well, since we have it sorted, first we're looking at this map. If that check failed, then we would look at this map. If that check fails, then it means that none of these like individual range maps, whatever map dictionaries, just to keep it a little more consistent, works. And so then we're not changing the value, which is says somewhere that if that aren't mapped, just go to the same number. So yeah, okay, that's part one. Now let's look at part two, which from the memes on the Reddit took a really long time. It was computationally complex. All right, part two. Everyone will starve if you only plant a small number of seeds. Rereading the almanac, it looks like the seeds line actually describes a range of seed numbers. The values on the initial seeds line come in pairs. Within each pair, the first value is the start of the range, and the second value is the length of the range. You need to contain the total. Rather than considering the 4 seed numbers, you need to consider a total of 27 seed numbers. Right, because it's 79, 80, 81, blah, 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 blah. 14 plus 13, 27 total. Okay. Got it. So now we're starting interpreting this as ranges. So let's first just yoink all this, put it into part two. And yeah, now we just gotta sort of deal with these as ranges. I think the issue, well, yeah. Let's let's do that. Let's go back to this this watch. So yep. Okay. So naively, what we could do is simply compute find all the seeds and just put that in a big list and then go through this thing the same. Just create, basically, instead of just having seeds set explicitly here, we have create a list of seeds, and then we sort of need to go through the pairs of this. How does line 0 look again? Like this. So yeah, okay, so this is going to be the seed pairs. And then to get the actual seeds, we need to iterate through the seed pairs. All right, let's do something a little fancy. So this is so unnecessary, but it's just, yeah, okay, it's kind of fun. That's the whole point of this, right? So we have, yeah, the seed start and the length. And then what we're going to do is get first every other seed pair, and then, whoops, every other seed pair offset by 1. So, see if this works. Why is this imbalance index? Oh, it's very obvious why it's imbalance index. Oh, okay, they're errors later, but yeah. Cool. Yeah, so we have seed start of 79, length of 14. And then similarly, start of 55, length of 13. So then the range generated by each of these is going to be pair seeds. Geez, we have seed pairs and pair seeds. Seed range. So here we're just out the range that we're creating using this pair. This looks like, yep, we're going 79 all the way up to 92, which is indeed going to be 14 new values, because that's plus 13. So then let's just call seeds.extend seed range. So we're dealing with a lot more seeds now. But we can find a solution. So we're getting 46, and that is correct. So this is going to be correct. However, I think it's going to be quite slow. But let's, yeah. Well, we can just now run this on the full thing. You can see, yeah, it's definitely slow. So let's use a TQDM. Killed. Oh, well, I don't know what's going on. Okay, to see how long this is going to take. This is a nice function which you can use to wrap your iterators, and it'll print out some info. Or not. Okay, so we're not even being able to create the seeds. Okay, got it. So this is using a lot of memory, evidently. Initially, let's try and make seeds a set instead. Let's see what we're working with here. What's the right method to add to union? Add, that adds just one element. I don't know, it just doesn't seem right, but so evidently we're creating a lot of seeds. A lot of seeds. Okay, well, probably gonna need to use an alternative approach. Okay, I can see why it's hard. I saw some people talking about how they like multi-threaded it, but that's just not, I think, what I'm interested in doing. Let's look at that input again. Yeah, so basically this is a big number. That's like this is like a number of seeds, which is crazy. That's a huge number. How do we make this more efficient? Yeah, it's just crazy. I don't know. Initially, yeah, I'm just like not really sure what to do here. There's a lot of seeds. It's a 9-digit number. Close to a billion. And it looks like we're not even close to that before we're crashing. Yeah, I'll take a couple minutes maybe to think about it. If not able to solve it, I'll probably look at a solution, then come back and implement that and talk about it. But let's try and solve it first. So yeah, what I'm thinking is there a more efficient way we can do this? Like, it's obviously not possible to check every one of these seeds. So it's just, when you put it through all these maps, I just am not really sure how we know, if there's even a way to know. Like, if we can sort of, it doesn't, there's no real way to reverse this. It would be, if we just have a single map, then it would be much simpler, because we know that like the minimum value that's going to be spit out of here is like, must be generated at like one of the endpoints of these ranges. So even though the ranges are ginormous, like, yeah. But then it gets weird because like a low value in this map just think about a simple example. Because numbers, as they go through this sort of pipeline, can get bigger and smaller. Yeah, all right, I don't know, this stumped me. I was not expecting this problem to be this hard, but I guess, yeah, it is. I'm gonna go look for hints. I don't know if I'd be, yeah, I think if I really wanted to solve this, probably would come back after a break, but I'm just a little impatient. So I'm gonna try and find a hint and then maybe come back to this. And yeah, I'll see you in just a little bit. All right, we're back. And yeah, so I don't think there's a super intuitive way of doing this, but I think we can solve it. From looking at the Reddit, it looked like some people did just brute force it. Obviously, Python, that's not going to be possible. Although it is, yeah, that was one approach. Another approach that I saw um, was highly mathematical and involved breaking up, um, breaking, like, thinking of each map as the union of, like, or its disjoint, whatever, it was mathy, piecewise linear functions, and like the fact that the composition of piecewise linear functions is also piecewise linear. So from that, you can like um, map, compose all the maps together. I don't know, it seemed hard. And then the final approach I saw, which I think is what I'm going to try and implement, though I didn't look at any code, or I guess I glanced at it, but I'm not going to be copying code, was instead of operating on individual seeds, is looking at whole seed ranges. So it's like sort of mapping ranges to ranges, which makes sense. I definitely should have thought of that. But yeah, implementing that is definitely not going to be straightforward, even with that little hint. Let's go back into this and just change up a couple of things before we do anything else. Let's set up this file watcher again. And yeah, so I think one thing I did look through some code. One thing that I saw was instead of doing this, like, I just did some weird stuff that I just want to clean up a little bit. So let's just clarify with our variable names, like how we're thinking about these things. So instead of map list, this is just a map. So like, this is one map, this is one map, this is one map. Yeah, and then I'm going to call each one of these within the map a line. Yeah. So also, instead of doing this like list of dictionaries, let's just append the list directly. And then we can unpack this. Just mark that it's destination source range. And I have to think about more if this sort is really necessary, but yeah, for now let's just ignore it. So I think this encoding we've cleaned up a little bit. Now let's go back. Let's just get the the part 1 solution working, and then we can do ranges. So let's instead call this line, and then we can get the source, destination, source. I don't really like this underscore syntax. You need to use it because range is a keyword, but let's just use it for now. Yeah, and just unpack the values of the line. Then we're going to change this to source, range, and then source and destination. And yeah. I think we can get rid of the DQDM. So it looks like this is working in with just like the part 1 implementation. I think these small things to just clean it up is nice. Okay, so now let's whoops. Let's make this, yeah, let's do the things a little bit differently. So we'll be encoding things the same way, but now we're going to follow each range through the maps. Yeah. So essentially what I'm thinking is, so we have 2 ranges. We then put those ranges through these 2 maps, and then we'll output a certain number of ranges. It's not necessarily going to be 2. In this case, I think we're going to get 2 again, because this range and this range, they're both mapped using the same line. But that's not necessarily true. But yeah. So we could get out, say, like 4 ranges, and then put those 4 ranges through the map, blah, blah, blah. Ultimately, at the very end, we should get a list of ranges, and then we can find the minimum of that really easy. The crux of this is, instead of mapping an individual value to an individual value, the map is mapping a range to a range. So let's try and implement that. Yeah. So I think we don't really need to just comment out what we have before. 0 to keep everything happy. And yeah. Why are we printing out? What are we printing out here? That's great. Yeah, so our initial ranges, yeah, let's have a list of ranges, and then essentially what we want is ranges. It's going to be a list of tuples. Yeah, just something like this. And let's just note that end will be I don't know, we'll just say end is inclusive. So we'll start out with ranges looking like since we're saying end is inclusive, just do a little -1 action. And now, yeah. I just know it's going to be a debugging nightmare, but yeah, okay, we have that. Now we have our initial ranges. Nice, nice. I think that we're now going to want similar to the individual value, we're going to want to iterate through the maps. But instead of having this outer loop where we go seed and seed, let's just do all of these ranges at once. Because, yeah, that just, I think that'll be easier. So I think what I'm going to want to do is create this helper function, which is map range, which is going to include a range, which is the tuple, and then the map, which is a list of tuples, 3 integers. And then this will return multiple ranges, which is going to be a list of so I think the hard part is going to be implementing this this function, this map range function. But I'm thinking, yeah, basically for each map, we're going to apply this function to the new ranges. So here we can do range and ranges. New ranges dot extend map range map. Yeah. And then at the very end, we want to return the bottom. We want to get the bottoms of each range, so we can call it starts elsewhere. And return the minimum of that. Okay. I guess we gotta import tuple. So this function is the hard part, implementing this function. And then let's just want to merge ranges. So if like the number of ranges is just ballooning out of control and they're overlapping, we can save a little time by merging them, but we might not need to do that, so that can save that for later, but that would be potentially an optimization. Okay, so let's now think about this map range. Let's just do an example. So you've got 79 to 92 and 55 to 13. I think that what we're going to want to do, let's just look at this range, is basically say similar to how we iterated through this map. I think we are going to want to do it the same thing in sorted order. So I had this like this to do that. Yeah, I think we do want this. Where what we're going to want to do here is go through each one of these lines and see basically if this applies. I think we can do this. Okay. Yeah, basically if part of the range is within this, then we'll use this to map that part of the range. Otherwise, we can keep going. Okay, so yeah, let's do this. I think what we're going to want to do is let's just do this. First, we'll unpack the range. Then do for list and map. So yeah, I don't know. Just call this length. Now we're just calling things other names. We'll go back to RG. And then this will just be unpacking the map. So essentially what we're going to want to do, and then instead of, we'll create new ranges as needed. So basically, first we want to check if this range if the start of the range is greater let's just calculate some more values, that'll be helpful. So the start of the range is the source. Oh, we have to unpack list, not map. Am I doing that up here too? Nah, whatever. Okay, so this is going to be the start and the end of the range. Let's just run a little instead of doing alt var2. Let's just do a little test case. What is our range? 79, 92. Okay, we can print some stuff out here. Okay. This is, I think we can get it right the first time, but if not, it's gonna be a nightmare to debug. Range is just a little overloaded, so I'm gonna go back to calling this line. See, I'm just crazy right now. We're calling this line, and then here, calling that the line offset, is destination minus source. Okay. So first, we'll check if the source is greater than the start of our range. In this case, let basically everything before everything from start to source in the range is going to be eliminated. Yeah. If source is greater than start, then Just because I can tell already that it's going to be weird, let's go back and just to make this not inclusive. So now we're working with 93. Yeah. So here we're going to want to create a new range where it's just mapped to itself. So the start will be start, and then the end will be min, end, and yeah. So basically, okay. So what I'm thinking that here, you sort of have to deal with the case where we're sort of processing this range from the start to the end. And this, I think, yeah, let's just write a test case where this is applicable. So we'll still use this map 0. So let's say we're going from 45 to 55. Make it easier, 49 to 51. We're running into this situation where we're updating the start of the range as we process it, and if it's equal to the end, then we just need to break out because we've already processed the full range. So why then are we printing this out 3 times? It's my little confusion. Okay, just being silly. We print out some other stuff before. As you can see, my brain is maybe not running at 100% capacity, but I think we can still make it this problem, or at least we'll try our best. All right. Yeah, so the map is going from 50 to 98. And so we have this first range created from 49, and it's of length 1, just a 50. Then we have the second range. So now this is going to be inside of the thing, inside of this line, what this line is mapping. So now we have a new if statement. Just switch the order of these to make it a little clearer for me. So now if start is greater than or equal to line start, or I guess more. Now if we're sort of inside where we want to be, we're going to create a new range. Where we have now we're going to take the minimum over the end and the line end. We have to remember to apply the line offset. I actually wonder if, can we just add to tool? Probably not. Yeah. Okay, so this is correct. Now we want to sort of deal with what if we're going beyond the end of the range, like beyond 98. So say we're going to 100. Okay, so the first time makes sense. The first time we go through this, it doesn't work. Then the second time, just add a little debug information here. So the first time we go through, range looks like that. I forgot about the second line. All right. For now, maybe let's imagine that there are no more lines. Imagine that there's just this one line. So essentially, if at the end of this, there's leftover line, then we're gonna need to add a new, add what's left. So 97 in this line, 97 is being mapped to 99. But then we're looking at 97 again, which is wrong. Because here we shouldn't be subtracting 1. Okay. So I think that this is a bit of a a cluster, but I think that this is now right. Maybe. So now we have this other range, which is going to map. So 97 is going to it. 49 and 50. 49 is going to itself. Then 50 to 97 inclusive are going to +1. So that's this. That's correct. And then we have 50 then we have finally this little thing. So 98 and 99 should be mapped to 50 and 51, which is correct. And then 100 is being mapped to itself. Okay, I think this is working. Certainly it might not be. However, I don't think we need this anymore. Let's just try it out. And see what happens. Already I can tell that maybe we do want to merge ranges though, because we're going from 1 to 4. Solution of 55. I don't think that was right. Yeah, that's not right. Oh man, this is gonna be a debugging nightmare, huh? Oh, we're doing something wrong though. Yes. Okay. Let's try that. Oh my goodness. This has been fun. This is a hard one though, for sure, for sure. Yeah, let's clean it up a little bit and then go through the solution. So we didn't end up needing to use this optimization, so just delete that. Any other like weird statements? No. Okay, let's just go through this quickly. Go through the part 2 solution quickly. Yeah, so here in part 2, we're coding in a slightly different way than part 1, but it's essentially the same, just clarifying some things from part 1. I'll actually go back and update part 1 before I upload this code so that it's using the same format. And the sort of the crux of what we do differently is instead of thinking about mapping individual seeds, is we're mapping ranges of seeds, because we can think of each range can be mapped to one or more ranges, and that's using this map. And here we just iteratively do that. And then finally, once we have this final ranges, we can find like the minimum of within those ranges by looking at the range starts and the minimum of those, because the starts are obviously the bottom of each range. So then we have this map range function, which looks a little funky for sure, but I think if we try and think about it together, we can make sense of it. So essentially, I'm storing the range start and end. What's key is that these are not immutable. We're sort of iteratively processing the range from the bottom to the top. And as we process it, the start value is getting updated. So this is just the output, since we output sometimes more than one range. Okay, and here we're just going through each line in the map. Where, like I'm repeating myself maybe too much, but each line is like one of these. So this is a whole map. This is each line of the map. And what's key is that the lines are sorted in ascending order of source. So here's just unpacking some values, like straightforward. It's like the start and end of the line. So instead of like using this like range notation, this is like this line is going from 0 to 7, 0 to 6 technically, 0 to 6 inclusive, and then the offset is going to be plus 42. That just makes some of these operations a little easier to understand. So now we have two main cases. The first being if the start of the range is lower than the line start. Since we're going in, since the lines are sorted, we know if we hit this statement that there's no other line that will match this part of the range. So in that case, what we can do is update the start to basically, we need to do this to where like the line starts. So hopefully that makes sense given that we worked through a couple examples, but in some cases here we have like, we can hit on the end of the range. So we don't want to like update the start so that it's greater than the end. Obviously that wouldn't make sense. And then we add to the ranges and then update the start value. Then in this block, we handle the case of if the range we're looking at is inside of the line, inside of the area that the line is mapping. So in that case, we're mapping from the start of the range, which has been potentially updated so far, to either the end of the range or the end of where the line maps from. And then notably what's different when we add this range is we apply the offset, because here we're essentially like not in a line, so we map directly back to each value to itself. Here we are in a line, so we have to apply the offset. Then yeah, we have this little statement, which I think is actually not necessary. Now things have been updated. It just makes it slow, I guess. So maybe, yeah. Yeah, I guess if the reason it's making it slow is because if start is equal to end, we're still like creating some ranges of length 0, which we don't want to do. So it does make sense to break here. Then finally, this is like, once we iterate through all of the lines, if there's any like range left that we haven't mapped yet, we append like a final range. Then we just apply that function a bunch of times, and yeah, since that function is correct, all we need is this very simple for loop to update the ranges as we go. So yeah, I think that's it for day 5. This has been sort of an interesting problem to reason through. It's probably like a visual explanation would be more helpful, which I don't really have the setup to do well right now. But yeah, as always, if you've got any comments or questions, please put them in the comment section below. Thanks for watching if you made it this far. And yeah, tomorrow I'll try and put up a video soon after the problem is actually released. All right,